Welcome, everyone. Today, we're going to build a really important bridge, one that connects the world of abstract mathematics with the very concrete world of business strategy. We're going to be talking about how that familiar U-shaped curve, the parabola, is so much more than just a graph in a textbook. It's actually a powerful predictive tool that can shape multi-million-dollar decisions and, honestly, determine the success or failure of a business.
So here's our roadmap for today's lecture. First, we'll ground this whole idea in a business context. Then we'll get our hands dirty with the mathematical mechanics behind it all. After that, we'll take what we've learned and apply it to a real-world problem to see it in action. And finally, we'll talk about some of the common mistakes to look out for so you can apply these principles correctly when it really counts.
All right, let's begin with the big idea. Any quadratic function, and that's just a fancy way of saying a function that looks like f of x equals ax squared plus bx plus c, while its graph is a parabola. And you know what? This shape shows up everywhere in business. It can model the relationship between the price of a product and your revenue, or the number of items you produce and your total costs. And why is that? Well, because business relationships are rarely a straight line. If you produce too few items, you don't make much money, but if you produce too many, your costs for storage or unsold inventory can actually cause your profits to go down. That up and then down dynamic, that's a parabola, perfectly describing the situation.
Now, I want us to keep this quote in mind throughout our entire discussion today. Our goal here isn't for you to become a human calculator, just mechanically plugging numbers into a formula. It's for you to gain a deep, intuitive understanding of why the formulas work and, more importantly, what they tell you about the business you're analyzing. That's what separates a technician from a true strategist.
Okay, let's dive into the details. To really use these functions to their full potential, we first have to master their core components. It's like a mechanic needing to understand the parts of an engine. We need to understand the anatomy of a parabola before we can use it to diagnose a business problem. So let's give these definitions our full attention, because they are the absolute foundation for everything we're going to build on.
First up, the vertex. From a business perspective, you could argue this is the single most important point on the entire curve. Why? Because it represents the absolute best-case scenario. It's either the maximum possible profit you can achieve, or it's the minimum possible cost you can incur. It is the sweet spot. It's the optimal point. It's the peak of your performance. And finding this exact point is pretty much the primary goal of our analysis.
Next up is the axis of symmetry. The best way to think about this is to imagine you could fold the parabola along this vertical line, right at the vertex. The two halves would match up perfectly. Now, in business terms, this has a really brilliant implication. It illustrates the cost of deviating from your optimal point. So, for example, if the vertex tells you that your optimal production is 1,000 units, the axis of symmetry shows that producing 100 units too few, say 900, will have the exact same negative impact on your revenue as producing 100 units too many at 1,100. It reveals the symmetric penalty for missing your target.
Now this one's really interesting. The discriminant. It might sound a bit technical, but it comes from the standard quadratic form, that ax squared plus bx plus c we talked about. The discriminant is just that little piece, b squared minus 4ac. But the value of that little piece tells you a powerful story about your break-even points, the points where your profit is exactly zero. C. If the discriminant is positive, it means your profit function crosses that zero line twice. That's great. It means there's a profitable zone between two break-even points. If it's zero, you have exactly one break-even point. But if it's negative, that is a massive red flag. It means your profit curve never even touches the zero line. It's telling you that your business model as it stands is fundamentally unprofitable. It's like a mathematical early warning system.
So, we've established what the vertex is and exactly why it's the key to our whole analysis. But now let's get practical. How do we actually find it? How do we pinpoint that one special spot? Well, this next section gives us the essential tool, the specific formula that acts as a key to unlock that optimal point directly from the function itself.
And here it is. This is the vertex form of a quadratic function. I really want you to get comfortable with this. Make it an old friend. Because while there are other ways to write a quadratic function, this form is, by far, the most direct and elegant for business analysis. And the reason is simple. The coordinates of the vertex, which we call h, k, are literally built right into the formula. It just hands you the answer.
Let's break it down piece by piece. First, you have the variable a. This tells you the direction of the story. If a is negative, the parabola opens downward, kind of like a frown, which means its vertex is a maximum point, perfect for modeling things like profit or revenue. If a is positive, it opens upward, like a smile, and the vertex is a minimum point, which is ideal for modeling costs.
Then you've got h. H is your decision variable. It's the x-coordinate of the vertex. It's the answer to how many or how much. How many units should we produce? What price should we set? And finally, you have k. K is the result of that decision. It's the actual tangible dollar amount of your maximum profit or your minimum cost.
Okay, so we've covered the theory. Now let's see how this all works in the real world, because the true test of any business tool is how it performs in practice. It's time to move from the abstract world of A, H, and K into a tangible scenario where these concepts are used to make a really significant financial decision.
So, I want you to imagine you're the manager. You're in the boardroom. The executives are looking to you for a data-driven strategy. A gut feeling just isn't going to cut it. They want a number, a plan backed by solid analysis. So how do you find that precise production level that hits the revenue sweet spot and gets the absolute most out of your company's resources?
In this scenario, let's say your market analysis team has done their homework. They've given you a function that models your company's total revenue based on the number of units you sell. Now, the beauty of a mathematical model like this is that it lets us take all those incredibly complex market forces, things like consumer demand, price elasticity, what your competitors are doing, and it distills them all down into a single elegant function, whose vertex represents our best path forward.
And here's our model. Now let's roleplay for just a moment. Imagine you are the chief financial officer. You're standing in front of your executive team with this on the projector screen. You wouldn't just read the equation out loud, right? You would bring it to life. You'd point to each part of this function and explain exactly what it means for the company's bottom line. So, continuing that role play, you would translate this math into a direct, confident business command. You'd look at your team and you'd say, all right, team, look at our model here. The H value is telling us our target is 1,500 units. The K value is telling us the prize is $4.5 million. The math is crystal clear. Our production target is 1,500 units, period. If we produce more or if we produce less, our revenue will go down. Hitting this exact target will yield our peak possible revenue of $4.5 million. See? That's the power of this formula. It gives clarity and confident direction.
Now, as with any powerful tool, there are ways to misuse it. And a small calculation error here isn't like a mistake on a homework assignment. In the real world, it can lead to a flawed strategy and some very significant financial losses. So let's spend a few minutes on the most common point of confusion I see so that you can avoid it. So this is absolutely the crucial point. Look very closely at the standard vertex form. It's A times the quantity x minus h squared. That minus sign is a built-in part of the formula. So because of that, when you see x minus 1,500 in an equation, the value for h is actually positive 1,500. If the equation had said x plus 1,500, you would need to read that as x minus negative 1,500, which would make h negative 1,500. You always have to take the opposite sign of the number you see inside those parentheses. It's a tiny, tiny detail that makes a world of difference. Getting it wrong means you're optimizing for the completely wrong production level.
Okay, so to summarize our session today, first, we've established that these quadratic functions, they aren't just academic exercises. They are vital, dynamic models for business reality. Second, we've identified their single most important feature, the vertex, as the representation of the optimal business outcome, maximum profit or minimum cost. Third, we've mastered a specific tool, the vertex form, that lets us pinpoint that outcome with precision. And finally, and maybe most importantly, we've highlighted that careful, critical interpretation is what turns a simple formula into a powerful strategy. I'll leave you with a final thought to carry with you as you continue in your studies. We've really just scratched the surface today with a relatively simple function. It really begs the question, what other, more complex mathematical structures are quietly shaping the strategies of the world's most successful companies in logistics, finance, and marketing? What we've done today is just the beginning of your journey into quantitative business analysis. So I encourage you, keep exploring, keep questioning, and keep learning. Thank you.